Water infrastructure gap is reshaping U.S. industrial growth. The conversation about constraints on U.S. industrial growth tends to circle the same variables: power availability, labor markets, land costs, permitting timelines. Water rarely leads that conversation, and that is starting to create real problems for companies that did not see it coming. The issue is not whether water exists. Most U.S. industrial regions have water. The issue is whether local systems can source it, treat it, move it, and discharge it at the scale that modern industrial demand requires. Across much of the country, the answer is uneven in ways that only become visible once a project is already in motion. A $625 billion gap that growth is now running into. The U.S. is in the middle of a significant industrial expansion cycle, driven by reshoring commitments, energy transition infrastructure, data center build-out, and logistics investment. The water systems underlying that expansion were largely built for a different era and a different scale of demand. The American Society of Civil Engineers gave U.S. drinking water infrastructure a D+ in its most recent report card, reflecting decades of deferred investment that have left treatment capacity, distribution systems, and discharge infrastructure running well below what current growth trajectories require. The EPA has estimated a funding gap of $625 billion over the next 2 decades for drinking water infrastructure alone. Wastewater adds another $271 billion on top of that, and neither figure accounts for the additional capacity that the current industrial expansion wave would require. While self-supplied industrial water withdrawals are a smaller percentage of direct freshwater use than other categories, they are part of a broader, rising demand surge driven by data centers and onshoring manufacturing. This intensifying need is outpacing infrastructure capacity in many regions, which was not designed for such rapid, localized growth. Consequently, the gap between required water volumes and reliable delivery is impacting permitting timelines, capital budgets, and site selections in ways that are becoming increasingly difficult to manage. In the Southwest, the terms of growth have already changed. In the Southwest, the water constraint is visible and has been for long enough that it has started reshaping how growth works rather than simply slowing it. The Colorado River Basin supplies water to roughly 40 million people across 7 states, and the Bureau of Reclamation reported in 2023 that Lake Mead was operating at levels not seen since it was first filled in the 1930s. That is not an abstraction for industrial operators in Arizona, Nevada, and parts of Texas. It is the baseline condition they are planning around. Projects that would have moved forward on relatively straightforward assumptions about water access are now subject to longer reviews, conditional approvals, and in some cases fundamental reconsideration of whether a site can sustain operations over a realistic operating horizon. Growth is still happening in these markets, but the question has shifted from whether a project can be built to whether it can run reliably over time. That is a different underwriting question than most capital models were built around. Partner with E+E Leader, interested in reaching sustainability and energy leaders through E+E Leader's executive audience? Learn about sponsorship, where water is available but the system is not ready. In high-growth corridors across the Southeast and Gulf Coast, the constraint looks nothing like the Southwest. Water is available. The problem is what happens to it after industrial operations generate it. Wastewater treatment capacity is tightening across fast-growing markets in this region, driven by population growth and industrial expansion, hitting systems that were not sized for both simultaneously. NOAA data shows the Southeast experienced a 27% increase in extreme precipitation events between 1958 and 2023. Putting additional stress on stormwater infrastructure that was already running close to capacity in a number of markets. Projects that clear the water sourcing question are running into permitting complications and unexpected capital requirements on the treatment and discharge side, often late enough in the development process that the cost of addressing them is significantly higher than it would have been at the site selection stage. Freshwater access is an advantage. Infrastructure readiness is not guaranteed. The Midwest and Great Lakes region holds what looks on paper like a structural advantage in a water-constrained environment. Access to fresh water at scale is genuinely valuable as other regions tighten, and site selectors have been paying attention to that. The interest the region is attracting reflects something real. What that narrative tends to skip past is readiness. Access to water and the infrastructure capacity to support industrial demand at scale are not the same thing. Many systems in this region are aging and capacity constrained, and the modernization investment required to support new industrial load has not kept pace with the inbound interest. The advantage is real. It is just not uniform across the region. And companies that assumed it was have encountered surprises during permitting and pre-construction review that were not in the original project timeline. The next wave of growth is heading exactly where systems are least prepared. A significant share of the industrial expansion underway or planned is targeting smaller cities and rural corridors, where land availability and labor market conditions tend to be most favorable. It is also where water infrastructure tends to be least prepared for industrial scale demand. The EPA estimates that water systems serving fewer than 10,000 people account for more than 80% of all Clean Water Act violations nationwide. That figure alone says something important about the infrastructure condition of the markets, where much of the next wave of growth is heading. Wastewater systems in smaller markets are frequently sized for residential and light commercial use. Industrial discharge requirements often exceed what those systems can handle without upgrades, and the timeline and cost of those upgrades can fundamentally change the economics of a project. In some cases, they have derailed investments that looked sound at the initial feasibility stage. The timeline problem that is showing up inside project budgets. Across all of these regional pictures, one thread runs consistently. A 2024 analysis from the Brookings Institution and other researchers indicates that permitting timelines for major U.S. infrastructure, particularly electric grid transmission and renewable energy projects, have grown significantly over the past 2 decades, with the average environmental impact statement, EIS, now taking over 4 years to complete, which represents an increase of roughly 1 year since the late 1990s. Capital models that carry permitting assumptions from a project completed 3 or 4 years ago in a different region are likely working from a baseline that no longer reflects current conditions. That gap between assumed and actual timelines is where a lot of project budgets are getting stress tested in ways that were not anticipated. Why water belongs in the room at site selection, not after it. Water infrastructure has earned a place in the same early-stage evaluation that executives apply to grid access and transportation when assessing growth opportunities. The companies treating it as a late-stage permitting concern rather than an early-stage site selection variable are the ones encountering the most expensive surprises. The practical adjustment is not complicated. It means asking the water infrastructure questions earlier with the same rigor applied to power and transportation, and building realistic timelines and potential upgrade costs into capital assumptions before a site commitment is made rather than after. The regional picture is uneven enough that assumptions carried over from a previous project in a different market can be genuinely misleading, and the data to make better decisions at the front end is more accessible than most site selection teams are currently using. The bottom line, the U.S. is not running short on water. It is running into the limits of the systems that manage and deliver it, and those limits are not distributed evenly across the markets where industrial growth is concentrating. The EPA's funding gap numbers make the scale of the problem concrete. The regional variation makes it a site-specific risk that general portfolio assumptions will not capture. The regions that capture the most value from the current expansion cycle will be the ones where infrastructure can actually support the scale and speed that operators need. For executives still treating water as a background utility in growth planning, the infrastructure data is the reason that assumption is worth revisiting before the next site decision, not after. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.